Okay, in this lesson we are going to finish learning about the basics of the inverse trig functions. Earlier we learned about sine and cosine inverse, and today we're going to talk about tangent inverse and then the other three reciprocal functions. So if you look at your tangent inverse function, just like we did for sine and cosine, we want to be able to find an area of the graph that represents all of the possible ratio values, positive, negative, 0, undefined, etc. So if we look at our graph with tangent, we can just pick one squiggle of the graph, and that one squiggle will represent everything. Now, like we talked about with our sine and cosine, we want to make sure that we represent everything without being redundant and having any overlaps, because if we were to have overlap, we would not be an inverse because it wouldn't be one-to-one. So if we consider this part that I've highlighted in yellow, and we find those three key points that we learned to graph. If we make a t-chart, y equals tangent x, just like we did with our other two functions, x is an angle and y is a ratio. Those 3 points are negative pi fourths negative 1, 0, 0, and pi fourths 1. So when we look at our tangent inverse graph, we can just flip-flop those values. And when we graph this one, just like we saw with sine and cosine, we have the ratio values on our x-axis, and we have the angle values on our y-axis. We plot those 3 points, and then just like how we talked about with sine and cosine, they may look linear, but they are not linear. It's going to have a little squiggle just like the graph does. Now, if you remember with our tangent graph, right here at pi halves and negative pi halves, we have asymptotes on our graph. And those asymptotes on the tangent curve are at x equals negative pi halves and x equals positive pi halves. So when we switch that into the inverse, recall that all x and y values switch. So now, instead of having a vertical asymptote, we have a horizontal asymptote at y equals negative pi halves and y equals positive pi halves. So our graph is going to end up looking like this. We have our asymptotes here, and then we will graph our little squiggle just like that. Now, a couple things that we need to recognize. On our sine and cosine graph, those graphs had points. They did not have arrows on the end because it was a fixed area that was stopped, because the ratio values went from negative 1 to 1, not bigger, not smaller, so those lines did not continue. With tangent, the ratio values, if we look at our original graph, they go up to positive infinity and down to negative infinity. So when we flip-flop that, since the y values on tangent used to go down forever and up forever, now when we flip-flop, the x values go left forever and right forever. And so that's why we will see arrows on our tangent inverse graph. And just like how we talked about with sine and cosine, we can call this graph the arctangent graph or the tan inverse graph. So when we talk about the restricted domain for our tangent inverse graph, this domain is going to be negative pi halves to pi halves. And here, notice that we have parentheses, not brackets. And we see these parentheses because we have asymptotes at negative pi halves and pi halves. Just like how those values were asymptotes before, they still are now. Okay, so if I were to do some tan inverse problems, like I see here, and we see tan inverse of root 3 over 3, the way that we want to think about this question would be, we want to say, what angle in negative pi halves to pi halves has a tangent ratio of, and then basically fill in the blank. And so this is the way that we need to think about all of these problems. So if I look at the first one, root 3 over 3, I know that that angle happens at my pi 6 reference angle, and since it's positive, then it would happen in the positive part of my interval. Therefore, the answer is pi 6. There is more than one answer that has a tangent ratio of 3/3. This also happens at 7 pi 6. However, 7 pi 6 is not in this restricted domain, which is why it's not a possible answer. If we look at our next question at tan inverse of -1, now that I have a negative ratio, that happens with my negative angles. Therefore, my answer would be negative pi fourths. Now, a lot of people want to say 7 pi fourths, and yes, those are the same spot on the unit circle. They are equivalent angles, but that number, 7 pi fourths, is not mathematically in the interval of negative pi halves to pi halves. If we were to look back at our graph and try and see where that would be, 7 pi fourths would be like way over here. And as you can see looking at this point, it is not within that highlighted squiggle for tangent. That's why that is not the correct answer. The correct answer would be this guy right here, negative pi fourths. Okay, so if we put all of that together, we can look at this chart that we see right here. Now, this chart is something that you are going to need to memorize, and I know it looks a little daunting at first. So let's just try and talk about some things that they have in common. First of all, if we look at our sine graph, our tangent graph, and our cosecant graph, all of these functions have our interval from negative pi halves to pi halves. Okay? And all of these functions, if we think about their values, have a y in the numerator. This is y over x, or sorry, y over r, y over x, and r over y. These are all of the functions that are either only focused on y or have y in the numerator. Now, our graphs that have the interval from 0 to pi are the functions that are more associated with x. So this is where we see x in the numerator, or only x in the ratio. That's how I remember them. Now, if we think about our domains, these are the ratio values that we learned about previously in the year. So we already know that sine and cosine have ratios from -1 to 1, and secant and cosecant have the ratios on the outside of -1 to 1. And we know that tangent and cotangent, those functions can have any ratio values possible. So even though this chart looks a little overwhelming when you first look at it, it's everything that we've already memorized. And when you try to remember with the ranges, which one of the functions have parentheses instead of square brackets, think about, well, which graph has the asymptotes that begin and end the interval? And that would be our tangent graph and our cotangent graph. So that is why those functions have the parentheses at the beginning and the end. And then cosecant and secant, these functions happen to have, that should say x. I'm sorry, I just realized I have a typo here. This is supposed to say that y cannot equal pi over 2. And the reason why that would be pi over 2 is because that is the previous angle that made our secant function undefined. And cosecant cannot have a y value of 0 because that is the previous angle that makes our sine or cosecant graph undefined. All right, so a diagram that I will frequently draw in class as we are doing these problems is that sine, its reciprocal, and tangent are all grouped together, and with this function, the angles that we are allowed to give are on this side of our graph. So the possible answers are only those guys. With our cosine, its reciprocal, and cotangent, the possible angles that we are allowed to give here are the top half of our graph. So everything in this region up here, okay? And the biggest thing that we need to remember is that for the sine, cosecant, and tangent graph, with those functions, these angles down here in the negatives are negative pi 6, negative pi fourths, and negative pi thirds. You're not allowed to give those like 7 pi fourths and so forth answers. Those aren't allowed. All right, so let's go ahead and take a look at these bottom couple examples. All right, so for this, what I want you to do is pause the video and answer the questions on your own and then check to see how you did. All right, so how did we do? Remember with cosine, secant, and cotangent, our answers have to be in this top interval of our graph. So when we see, for example, on letter D that we have a negative ratio, we know that that has to be in quadrant 2 as opposed to being in quadrant 4. If you think about it, if you tried to give an answer in quadrant 4, well, secant's not negative in quadrant 4, which is another way that we can remember the answer has to be in quadrant 2. With all of these questions, our unit circle is going to be so important. So if you've gotten a little rusty on that, you want to make sure you study. And our bottom section is now in degrees. And here you're going to approach these problems the exact same way. The only difference is that it says to find the degree measure, and therefore your answers for cosine, secant, and cotangent will be in that 0 to 180, and for sine, cosecant, and tangent, it'll be from negative 90 to 90. And again, using either parentheses or brackets, depending on which function we're working with here. All right, that is all. One last thing that I want to mention. You'll recall back earlier in the year whenever we had to use our inverse buttons, when sometimes we would get negative answers and you guys were wondering, well, why do we get a negative here and why do we get a positive here? And my common answer was, I know you don't understand now at this point, but you'll get it in chapter 6. Well, this is when you get it. The calculator understands those restrictions. So that's why when you would, if you would type in, for example, sine inverse of negative point, oh, that's my alarm, time to wake up, negative 0.6, it's going to give you a negative angle because the calculator knows that sine, when the sine ratio is negative, that you have to be in this lower portion of quadrant 4 with a negative angle. Okay, now that's really it. All right, have a nice day.